We're looking at a problem here where we want to add two expressions that have radicals. 7 root 18 plus 5 root 8. Well, on the surface, we can't add them because they have different radicals. Root 18 and a root 8. But I also see root 18 and root 8 as numbers that maybe will be able to be reduced down. So let's rewrite or reduce 7 root 18. Remember, to reduce that root 18, I want to turn it into a factor such that one of its factors is a perfect square. And root 8, that's a 4 times a 2. Alright, 7 times the square root of 9. Well, the square root of 9 is a 3, so I can pop them out. So that's 7 times a 3 square root of 2 plus a 5 times a 2 square root of 2. See how this 2 came out? Square root of 4 pops out, makes it a 2. So now I have 21 square roots of 2 plus 10 square roots of 2. Now everybody's talking square roots of 2. I can add them up. 21 2's plus 10 2's gives me 31 square roots of 2. So I was able to add those two original expressions together. Once I realized that, maybe I can reduce them down, or not reduce them, but simplify them a little bit. Let's look at another one. I have 4 root 27x minus 8 root 12x. Well, initially, I can't add or subtract them because they have different radicals. But I've realized I can factor some of these guys, or not factor, but I can remove some of these guys. 27, that's a 9 times a 3 times an x, minus 8. 12 is a 4 times a 3 times an x. So I were able to find some factors. Some of those factors were perfect squares, which means I can go ahead and pull them out. So 4 times a 3, square root of 9 is a 3. 3 and x stay inside. Minus an 8 times a 2 with a 3x still inside. So I have 12 square roots of 3x's minus 16 square root of 3x's, which gives me negative 4 square roots of 3x's. One more solution, or one more problem for you. I have 7 square roots of 3 minus 2 square roots of 5. I want to add those guys together, or subtract them. Can't subtract them because they have different radicals. Square root of 3, square root of 5. The only thing I can look at is maybe I could rearrange them and reduce that down, or simplify them in such a way. But 3 doesn't have any factors that are perfect squares, and 5 doesn't have any factors that are perfect squares. I can't change these guys at all. They're done. So my final answer was actually the problem I started with. It was already reduced. It was already simplified. I hope you were able to pick up a little bit on those differences as we did those last 3 examples.